day, grade 12 learners. Welcome to today's technical science lesson. My name is Lebogang and my surname is Teledi. This lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Center. So now for today's knowledge area, we'll be focusing on mechanics, wave, sound, and light. And for today, we'll be focusing on doing revision for paper 1, which has a total of 150 marks. Now the mark allocation for paper 1, it has your section A, which consists of 10 multiple choice questions. That has a total of 20 marks. Then you have either 8 matching items or one-word items, which has a total of 8 marks. Next, you have your section B, which consists of structured or long questions and has a total of 122 marks. Then the total for your paper 1, the mark allocation there is 150 and the duration being 3 hours. Okay, now in terms of the content, the paper 1, you have your mechanics, which has a total of 93 marks. You have electricity and magnetism, which has a total of 33 marks. Then you have your waves, sound, and light, which has a total of 24 marks there. Now for paper 1, for the June examination, you will be having your multiple choice questions, which have a total of 20 marks there. Then you have your forces and Newton's law, which has plus minus 25 marks. Then momentum and impulse, which has plus minus 25 marks. Your work, energy, and power has plus minus 25 marks there. Then you have elasticity, plus minus 10 marks. Your viscosity, plus minus 5 marks. Hydraulics, plus minus 10 marks. And your light, which has plus minus 15 marks. Then last one is your electromagnetic radiation, which will have a plus or minus 15 marks there. Now your quick wins in terms of your paper 1, you need to know the definitions. And then for all the definitions, you need to refer to what? You need to refer to the examination guidelines. Now remember, for the definitions, you are either going to get what? 2 marks or nothing. So you need to make sure that all the definitions, you get them specifically from the what? From the examination guidelines. Then the next one, all long questions in section B will require you to remember a definition or 2, and these are easy marks. Okay. Then the next one, the importance of what? The importance of the data sheet. And it says, and how it relates with the definitions and the theories, the laws, or the principles. So remember, each definition carries what? Each definition carries 1 mark. So you should make sure that you know, you understand your data sheet. The next one is your routine calculations that carry 3 marks. So for your routine calculations, we are going to have what? We're going to have the formula. Remember, we are saying the formula, it carries what? It carries 1 mark. And then the correct substitution. But with the correct substitution, remember, you need to write what? You need to write the correct conversion as well. So the substitution, it can carry 1 mark. Then you also need to have the correct answer that will include what? That will include the unit and the direction. So for routine calculations, you can get 3 marks. That is 1 mark for the formula, 1 mark for the correct substitution, and finally 1 mark for the correct answer. Okay. Next one, mathematical skills. It says the use of mathematical formulae that is provided in the data sheet. So again, we said you need to make sure that you use what? You use your data sheet. And then you need to make sure that you understand what? Scientific notation, because other chapters in paper 1, they require you to write your answers in what? In scientific notation. So for this one, you need to make sure that you use a calculator that you are familiar with and you understand that calculator. Then you need to make sure that you what? A conversion of units. So have the right conversions, know the conversions. And then whenever we have vectors, remember, When we speak about vectors, then we're speaking about what? A physical quantity which has what? Which has magnitude and what? Magnitude and the direction. Okay, so remember we said the word magnitude is what? Is the size. And then the direction, then we are saying, is the object moving to the right or is it moving to the left? That will be our direction there. Next one, we have what? We have the interpretation of the graphs there. Then when it comes to Newton's laws, you should make sure that you know the definitions. So the definitions that we have there, according to the examination guideline, your normal force, frictional force, acceleration, inertia, mass, and the tension. Okay, so for the definition, remember we said that you are going to have what? 2 marks. Then number 2, make sure that you know at least how to state the laws. So we have Newton's first law, second law, and Newton's third law. So again, that will be what? Another 2 marks there. Then next, you need to know or differentiate as well how to draw a free and a force diagram. So remember, with a force diagram, you are going to represent your object using the box, and then with the free body diagram, you are going to represent the object using what? Using a dot. So if you are then able to write or to draw the free body diagram or the force diagram, you can have a minimum of 3 or 4 marks there. Number 4, for Newton's law, make sure that you write what? You are able to write the formula there. So we'll have the formula of what? Of F net is equals to MA and the kinetic friction there as well, right? So how many marks can you then collect without you having to do any of the calculations? So it means that you can collect about 9 marks before you even do what? Before you even do the calculations. Where will the 9 marks come from? We said it will come from the definition, it will come from the law, it will come from the free body diagram, and at least 1 mark for you writing what? For you writing a formula. But you don't only write the formula, you need to write the formula and then do what? And then you substitute. That is where you are going to have what? That is where you are going to have a mark for the formula there. Then next, in terms of the multiple choice questions, it says you start by carefully reading the question, okay? Then next, what is it that we need to do? You need to underline the keywords in the question. Then you need to pay attention to the words that are capitalized. Decide whether you are required to recall use effect phenomena, definition, a unit, or a formula. Then next, you are going to do what? It says first eliminate the answers that are obviously incorrect. And then finally select the correct answers from the others that remain. Then it says this is called what? Elimination. And it's particularly helpful when the answers or options are very close to each other. Then the last one, it says you need to allocate what? Sufficient time for multiple choice questions. So if you have 20 multiple choice questions and those 10 multiple choice questions are what? Are 2 marks each, then it means that you can allocate at least 2 minutes for each multiple choice question there. Okay, next one, we have an activity here. So it says 2 horizontal forces, okay? So those forces are what? F1 and F2. It says they act on the same object, which is where? Which is on a horizontal surface, okay? Then it says the resultant force on the object is what? The resultant force on the object is 0. So if the resultant force on the object is 0, it means that F net is equals to what? F net is equals to 0, okay? So we have our information there, and then we also have the diagram. We can see that the one force is to the right, that is our F2, and then the other force is to the left, that is our F1. Then it says F1 and F2 have, okay? So which law is this one? Immediately when we see that the resultant force is equals to 0, then we can think of what? We can think of Newton's first law, which says what? If an object is at rest, then it will continue to be at rest. So in this case, the object is what? Is at rest. or it says if an object is in motion, it will continue to what? It will continue to be in motion. Okay. So if an object is at rest, it will continue to be at rest. And when it is at rest, then we have what? We have balanced forces. Okay. So if we have balanced forces, it means that therefore these two forces, if they are balanced, it therefore means that they must be equal in what? Equal in magnitude. Okay. So then we can then go and look at the options that we have. The first one, A, it says different what? Different magnitudes and opposite direction. So it means that this will not be our answer, because we know that the two forces must have what? They must have the same magnitude. And then option B, it says what? It says that different magnitudes again and the same direction. So we know that this will not be our answer, because we know that the two forces must be equal in what? Must be equal in magnitude there. So, okay, so it says that, so we have option C and option D. So these two forces, they must be equal in magnitude, but then what do we know? If they're equal in magnitude and one is facing to the right, one is facing to the left, it therefore means that they will be having what? They will be having opposite what? Opposite direction. So option D says the same magnitude and the same what? In the same direction. So again, therefore, that will not be our answer. So what is it that we know? We know that these two forces have the same magnitude. So if they have the same magnitude, we are saying that they have the same force. So for example, if the force of this one is 40, it also means that the force of this one is what? Is 40. But the force of F2 is 40 to the right, and the force of F1 is 40 to the what? Is 40 to the left. So we are saying option C because they have the same magnitude. As an example, we are saying that magnitude is what? Is 40 and 40, but they are opposite in what? In direction. How do we know that they're opposite in direction? Because we are saying that this arrow is facing to the right and this arrow is facing to the what? Is facing to the left. So equal in magnitude, but opposite in what? But opposite in direction. Okay, so our answer will therefore be what? It will therefore be option C there. Next one, it says two forces of 100 Newton each are simultaneously applied to a stationary crate that is placed on a horizontal surface. Okay, so two forces of what? Of 100 Newton each. So we can see the 100 Newton are simultaneously applied to a stationary crate. Okay, to a stationary crate that is placed on a horizontal surface. Okay, one of the forces is horizontal and the other one is applied at an angle. Okay, so that is very important. One of the forces is what? Is horizontal, and the other one is applied what? At an angle. Okay, theta to the horizontal. Okay, now it says the crate. Okay, so now we can see that they're talking about movement. Does it move at a constant velocity? Okay, so if it moves at a constant velocity, it means that the acceleration must be 0. Does it accelerate to the right? Does it accelerate to the left? Or does it remain at what? At rest. Okay, so with this one, what is it that we need to think of? We need to think of Newton's second law, which says what? Which says that when an object, when a net force is applied to an object, the object will accelerate in the direction of the what? In the direction of the net force. But with this one, we can see that even if we know Newton's second law, we are not able to answer. So it means that maybe we must be able to do some sort of what? Calculation. So what is it that we are going to do? We can firstly have our free body diagram there to say that, okay, on the left-hand side, what is it that we have? We can say that we have an applied force, which is what? Which is 100 Newton. And then on the right-hand side, what is it that we have? We have another applied force, which is what? Which is 100 Newton. But in terms of components, what are the horizontal forces that we have? We are going to have the applied force on the left, and then on the right-hand side, we are going to have what? We are going to have Fx. So when you break down the Fx, what is it going to become? when you break down the fx, so we have fx, when you break it down, it becomes what? F cos theta, okay? So if it's F cos theta and then you substitute the F, what is the F that is given? It's 100 Newton, right? 100 Newton, and then cos of what? Cos of, so here, as an example, I wrote that if, let's say, you have an angle of what? You have an angle of 30 degrees as an example, because we can see that this angle that is here, this angle that is here is less than what? Is less than 90 degrees. So if we can use, as an example, if we can use any angle that is less than 90 degrees, you will see that whatever answer that you are going to get will be less than what? Will be less than 100 Newton, okay? So in this case now, what are we saying? We are saying on the left-hand side, we have 100 Newton, but the answer for the right-hand side is what? Is 86, 60 Newton. So we can see that between the two forces, between the left-hand side and the right-hand side, where do we have the bigger force? We have the bigger force on the left-hand side, and then we have the smaller force on the right-hand side. So it therefore means that if you are therefore to calculate, it will be F net is equals to, so the force on the right is your force applied minus the force on the left is the force applied minus the force on the right, which is your Fx. So let's say that now we take the left-hand side as what? As positive. We are therefore saying our applied force is what? Is 100 minus 86, 60 that we got there. So if you find whatever answer there, you will see that you are getting what? You will see that you are getting a positive answer. So it therefore means that the net force will be directed in which direction? It will be directed to the left-hand side there. So again, we said that with Newton's second law, it says what? When a net force is applied on an object, the object will accelerate in the direction of the what? In the direction of the net force. So we are saying that because you will get a positive answer, it therefore means that the direction of the net force will be in which in which side is going to be to the left-hand side. So again, it therefore means that then your answer then should be what? Is it going to move at a constant velocity? So it's not going to be moving at a constant velocity. Is it going to be accelerating to the right? It's not going to be accelerating to the right. Does it remain at rest? It does not remain at rest. So therefore, it means that the only option left there for you would be what? It accelerates to the left. Why? Because we are saying that when you calculate the net force, you are getting a positive answer. So the direction of the net force is in which side? It's going to be to the left-hand side there. Next one, there says two blocks, X and Y, with masses of what? So we have two blocks that are what? That are X and Y with masses of what? Of 5 and what? And 3 kilograms respectively. It says they are stationary on a rough horizontal surface, okay? So what is it that we see here? It says they are stationary on a what? On a rough horizontal surface. So immediately when we see the word rough, then we can think of what? We can think of the friction. The blocks are connected by a light inextensible string. Then it says when force F with a magnitude of what? Of 25 Newton. So we have this force here of what? Of 25 Newton, making an angle of 28 degrees with the horizontal. So there is our 28 degrees with the horizontal. It says is applied to the what? To the 5 kilogram block. And then what happens? Both blocks move to the left there. Okay, so the first one there says 2.2.1 state Newton's second law of motion in words. So we already said when a net force acts on an object, the object will accelerate in the direction of the net force with an acceleration directly proportional to the net force and inversely proportional to the mass of the object there. Now remember again, for definition, it's going to be what? It's going to be 2 marks or nothing. And again, remember, you define according to the examination guideline. Then 2.2.2, draw a free body diagram with labels and identify all the forces that are acting on what? On the 3 kilogram block. Okay, so what are we going to do there? When we draw a free body diagram, remember we are going to represent the object using a dot, okay? So what are the forces that we have on the 3 kilogram block? So we have the what? We have the normal force, and then we have the gravitational force there. Then on the right hand side, what is it that we have? Or on the left hand side, we can see that from the rope, we have what? We have Ft, which represents the tension. And then on the right hand side, what is it that we have? We have Fk, which represents what? Which represents the kinetic friction. Why are we speaking about the kinetic friction? Because they spoke about what? They spoke about a rough surface, okay? So remember, with the free body diagram, whenever you draw your forces, you need to make sure that all the forces, they touch the dot, okay? And then you need to make sure that all the forces have arrows, okay? Then next, you need to also make sure that you have labels. So you cannot just draw the arrows and not label the forces, okay? Then again, we need to take note of what? Of the mark allocation. So normally if it's 4 marks, then we know that we need to provide how many forces? 4 forces. If it's 3 marks, then we need to provide 3 forces. If it's 5 marks, then we need to provide 5 forces. So very, very, very important. Let us look at the mark allocation. Let us make sure that the arrows are touching the dots. Let us make sure that we also draw the arrowheads, and then let us make sure that we label it, because that is where, remember, we are going to collect or to get those 4 marks of the free body diagram. Then it says we need to, it says the coefficient of kinetic friction for blocks X and Y are 0,2 and 0,1 respectively. So remember we said that we have what? Remember we said that we have friction. Why? Because of the key word what? Rough surface. So if they spoke of a smooth surface, then we know that we do not have what? We do not have the kinetic friction. Okay. Then calculate the magnitude of the normal force on block X. Okay. So how do we calculate the normal force? We are going to use the formula what? Fg minus Fy. So remember, for block X, it was a pulling force. So when it's like this, we call it what? We call it a pulling force. And then when we have a pulling force, then you need to make sure that you know the different scenarios or the calculations for what? For the normal force. So when it's a pulling force, then we are saying the normal force is equals to Fg minus what? Minus Fy. And then from there, you need to do what? You need to break it down. So if you have Fg, it becomes what? Mg. And then this is what? Minus Fy. So it will become what? F sine theta. So remember, when it comes to your formula sheet, you are not going to get this formula. So you need to make sure that you memorize or you understand and know how to apply this formula here. So what if you had what? What if you had a pushing force? Also make sure that you know how to calculate the normal force for that. So if you had a pushing force, then the normal force would be equal to what? Fg plus by Fy. And then when you break it down, it becomes what? Mg plus by F sine theta. So for now, what is it that we have? For now, we have the pulling force. So it means that we have the scenario here. We have the pulling force. If we have the pulling force, we are saying that our normal force is equals to Fg minus F sine theta. Then what was the mass? So remember, the X is the 5 kilogram block, and then your gravitational acceleration constant, where do you get it? On your data sheet there. And then remember the force, this one here, it was given as what? It was given as 25 Newton with an angle of what? With an angle of 28 degrees. So that is where we are getting our 28 degrees and our 25 degrees there. So from there you can calculate and you'll get your answer as 37,23 Newton. Okay, so again, the last one, if you have an object on a horizontal surface, then what is it that you are going to have? You are going to have the normal force there and the gravitational force. So if you are going to draw the free body diagram, you will have normal force and the gravitational force at the bottom there. You also need to know how to calculate the normal force for this scenario. So the normal force will be equals to what? Fn is equals to Fg. So it's this one, Fn is equals to what? Fg. And then what is your Fg? Your Fg becomes what? Mg. So therefore it means that you will then be calculating, you will then be substituting the mass and the gravitational acceleration constant there. So make sure that you know the three scenarios. So it's this one, the one with a pushing force, and then number 3 with a pulling force there. Next one says, so we need to calculate the magnitude of the acceleration of the system of the blocks. And then it says start with a separate equation for each block and subsequently solve them. Okay. So again, if you want to calculate the magnitude of the acceleration, what is going to assist you? It's going to be the free body diagrams. Okay, so we already had the free body diagram for the 3 kilogram block. So it's going to have what? It's going to have the normal force there, and then we have the gravitational force. We said on the right. On the right we have friction, and then on the left we have what? We have the tension. Then the next one, for the 5 kilogram block, what is it that we have? So this one will have the normal force, and then we'll have the gravitational force, and then on the right, what are we going to have? We have tension because we have the rope there. And then they said that they gave us the coefficient of kinetic friction for both of them. So meaning that for both of them, we have what? We have the kinetic friction. Then on the left-hand side, what is it that we have? We have the applied force. So on this one, I'm just going to draw the free body diagram. That will have what? That will have your components there. So it means that we are going to have Fx, and then at the top, we are going to have what? We are going to have our Fy there. So what is it that we are going to focus on when we are calculating the acceleration? We are going to focus on the horizontal forces. Okay. So let us start with the one for X. What are the horizontal forces that we have? So number one, let's focus on the movement. Where is it moving? They said that both blocks are moving to the left-hand side. Number two, let us focus on if it's moving to the left-hand side, what is what are the forces that we have on the left-hand side? Because wherever it's moving, that's we are going to be starting with those forces there. So we can see that we said that it's moving where? It's moving to the left-hand side. And then on the left-hand side, what is it that we have? We have Fx, okay? So we have Fx. Remember, we said we are going to focus on the horizontal forces. So what are the horizontal forces for X? We have Fx, we have Ft, and then we also have what? We also have Fk. Those are the horizontal forces. So meaning we are not going to be focusing on the normal force, gravitational force, and Fy. We just focus on the three forces, right? So now we are saying it's moving to the left-hand side. So if it's moving to the left-hand side, we have what? We have Fx minus. Okay, so we started here, F net is equals to MA, which is this step here. Then we are saying because it's moving to the left, therefore Fx minus, but because the two forces are on the same side, Fk and Ft, what is it that we can do? We can add the two forces, okay? So Fk plus Ft, we are adding them because they are on the same side, right? So next, what can we do? We can then multiply the negative into the brackets there. So if you multiply the negative into the brackets, you will have Fx minus what? Minus T minus the Fk, right? So you also need to know how to use the formula for what? For the kinetic friction. And then what is it that we know about the formula for the kinetic friction? It will be Fk multiplied by, formula for the kinetic friction is Fk, which is equals to the coefficient of kinetic friction multiplied by what? Multiplied by the normal force, okay? So it is this part there, right? So from there, we are saying that what is it that we have as the force? Remember this one? It was given as what? It was given as the 25 Newton. And then next, so it's going to be 25 cos of 28 degrees there, because the angle there is given as what? The angle is given as 28 degrees. Then minus what? Minus the tension. And then what do we have for the coefficient of x? It said the coefficient of kinetic friction for block X and Y are 0,2 and what? And 0,1 respectively. So it means that we are therefore going to substitute what? We are therefore going to substitute the coefficient of kinetic friction. And then remember, on the previous question, we calculated the what? On the previous question, we had calculated the normal force, okay? So from there, it means that you are going to solve whatever that you have on the left-hand side, and then on the right-hand side, you will be left with what? You'll be left with the 5a. Then if you solve whatever that you have on the left-hand side, you will see that it gives you what? 14,62, and then you transpose. So you will therefore have, for equation number 1, your answer will be 14,62 minus the 5a. So remember, what's important with this one is that you need to make sure that you make tension the subject of the what? The subject of the formula. And then when you make it the subject of the formula, it therefore means that you also need to make sure that it does not remain as a what? It does not remain as a negative. It needs to remain as what? As a positive, so that you are able to solve your equation there. Then we need to solve for what? Solve for y now. So again, for y, what is it that we are going to use? We are going to use the horizontal forces. So we said we have normal force, gravitational force. On the left, we said we have kinetic friction, and then on the right, we said we have what? We have tension. So what are the horizontal forces? So again, step number 1, we said, where is it going? It's moving to the left. So if it's moving to the left, we are therefore going to say what? Whatever that's on the left minus whatever that's on the right. What is it that we have on the left? We can see that we have tension. So we say tension minus what? Minus what is on the right. Why? Because those are the horizontal forces. We are not going to be focusing on the horizontal forces. Okay. So now, when it comes to this one, we can see that this one is not a pulling force or a pushing force. So therefore, what is the formula of calculating the normal force? The normal force, we are going to get it by saying normal force is equals to Fg. So normal force is equals to Fg, and then that Fg becomes what? Mg, right? So now we need the formula of the kinetic friction. What is the formula of the kinetic friction? Fk is equals to mu k multiplied by what? Multiplied by the normal force. So the mu k, it's a constant. It was given as what? As 0,1. The normal force, we are saying when we break down the formula from that, we are going to get what? Mu K multiplied by mass multiplied by M times G. So now what do we have there? We said we have tension on the left-hand side minus what? Minus Fk is equals to Ma. Now, it will then again be tension minus, so the coefficient of kinetic friction is given as what? Is given as 0.1. So we substitute there. And then from there, multiply by the mass. What is the mass that we are dealing here? We're dealing with the 3 kilogram block. So we substitute 3 kilogram block there. And then the gravitational acceleration constant is what? Is 9.8. It's a constant. You get it from the data sheet. We substitute. And that is equals to what? Is equals to 3a. Okay. So then again, we need to solve. So when we solve this one here, it gives us what? It gives us 2,94. So what did we do? On the right hand side, we had 3a, and then we solved for the kinetic friction. So when you take it to the other side, it will therefore change in sign and become what? And become positive. So again, remember, you need to what? You need to make T the subject of the formula. And then when you make T the subject of the formula, you must make sure that it remains a positive. Okay? So therefore, that will then be your equation number what? Equation number 2. So from there, what are you going to do? You are going to equate equation number 1 to equation number 2, or number 2 to equation number 1. From there, how are you going to solve? You are going to put your like terms together. And then how will you do that? So it means that from this step, it will be 14,62 minus 2,94. That is equals to what? 3a plus by 5a. Okay. So you get your answer on the left. And then this one is what? Is 8a. And then therefore, it means that you are going to divide by 8 on both sides. And that should then give you your acceleration there, which is what? 1.46 meters per second squared there. Okay, so that is how you are going to calculate the acceleration, or the magnitude of the acceleration. And then what did they say here? They said calculate the magnitude. So because they said calculate the magnitude, it therefore means that we are not going to give the direction. Magnitude means what? It means that they just wanted you to give the size, okay? So if it's just the size, it means that there is no what? There is no direction. So therefore, we are going to leave our answer without the direction. 2.2.5, it now says that you must calculate the what? You must now calculate the tension. Okay, so how are you going to now calculate the tension? It means that after you have now between equation 1 and equation 2, which has a positive tension, okay? So between equation 1 and equation 2, which has a positive tension, you are going to take any of the equations, okay? So in this case, it means that we used what here? We used equation number 1. And then it therefore means that our equation number 1 was then T is equals to 14,62 minus what? Minus 5a. Okay, so what is it that we did there? Rewrote then, and then what happened? Multiply by 5. So all that we are going to do is we are going to substitute with the acceleration. And what is the acceleration? Remember, we had previously calculated, so our acceleration is 1.46. And then you punch that into your calculator, it should give you an answer of 7.32. But you also have an option of using equation number what? An option of using equation number 2. So you can also say T is equals to 3a plus by 2, what? 2.94. And then what are you going to do? You are going to substitute by saying 3 multiplied by 1.46 plus by 2.94. So when you do that, that should give you exactly the same answer, and of which it can be different, maybe with 1 or 2 decimals. Okay, so that is how you can also use this tension to verify if your answer is correct there. Next, we have linear momentum and what? Linear momentum and impulse. So again, for the definitions, we have momentum, impulse, isolated system. So that is where you can get what? That is where you can get your 2 marks. And then number 2, be able to state Newton's second law in terms of momentum, principle of conservation of linear momentum. That is where you can get your what? Your other 2 marks. So already we have how many marks in terms of linear momentum and impulse? We have about 4 marks, and that is without us even doing any calculations. And then number 3, you need to distinguish between elastic and what? And inelastic collision. So for this one, that is where you can, sometimes in the question papers, you can get a question saying that state if ever the collision is what? Is elastic or inelastic. So normally for that statement, then you would then be allocated a total of what? A total of 1 mark. But if it becomes, when it comes to distinguishing between the two, then we can speak of maybe 2 marks for elastic and 2 marks for inelastic, or maybe 1 mark for elastic and 1 mark for the inelastic collision. Okay. Then number 4, formula and substitution. So on this one, that is where you are able to use at least what? At least 2 formulas there. And then the application of what? And the application of impulse there. Okay. So again, we are saying you can collect at least 8 marks, or a minimum of how many marks? 2 marks for the definition, 2 marks for stating the principle there, and at least 1 mark for the formula and the substitution. So that should at least give you a minimum then of how many marks? Of 5 marks there. Okay, so in terms of the tips, it says read the scenario carefully and underline the keywords. Okay, that is what we should always do. Remember that velocity, momentum, and the change in momentum, the average velocity, they are all what? They are all vectors. So remember, very, very important. When it comes to momentum, we need to emphasize on the direction. So you will choose for yourself. For example, if it says the object is moving to the right, then you know that you take right as positive. Object is moving to the left, you take your left as your negative. Okay. So emphasize on it emphasizes on vectors. And then when we speak of vectors, we're speaking about what? Direction. So again, it says always take direction into account. Why? Vectors. A physical quantity with what? Magnitude and what? And direction. Refer to the datasheet when carrying out the calculations. Pay attention to the mark allocation again. And then we have what? We have the elastic collision. It says the total momentum and the total kinetic energy are what? Are conserved. Okay. So total momentum, we are saying that the sum of the momentum before the collision will be equal to the sum of the momentum after the collision. Elastic collision, the total momentum is what? The total momentum is conserved. Meaning the momentum that you have before the collision and the momentum that you have after the collision conserved, meaning they will be the same. And then it says the total kinetic energy is also what? The total kinetic energy is also conserved. So meaning EK initial will be equal to the sum of the, the sum of the EK what? The sum of the EK final. So elastic collision, total momentum is conserved, meaning the momentum you have before will be equal to the momentum that you have after the collision. What about the kinetic energy? The sum of the kinetic energy that you have before the collision will be equal to the sum of the kinetic energy that you have after the collision. Okay, so in elastic collision now, what are we saying? A collision where the total kinetic energy is not conserved and the momentum is what? Is conserved. So now with this one, with the inelastic collision, what are we saying? We are saying that the sum of the momentum before is conserved, or it's the same as the sum of the momentum after collision. But we are saying that in terms of the kinetic energy, We are therefore saying that the sum of the kinetic energy before the collision is not equal to the sum of the kinetic energy what after the collision. Okay, so know and understand how to apply elastic and inelastic collision. So for the last time, inelastic collision, we are saying that the sum of the momentum before the collision is equal to the sum of the momentum after the collision. But then we are saying that in terms of the kinetic energy, the sum of the kinetic energy before collision is not equal to the sum of the kinetic energy after the collision. So what is it that we can see that it is in common between elastic and inelastic? We can see that in both the scenarios here, or in both the definitions, we can see that the momentum is what? The momentum is conserved. So the momentum is the same before and after the collision. The only thing that's not the same is the total kinetic energy. Okay, next one, we have the application of momentum impulse and the change in momentum. Okay, so for this one, if they ask you what is the application, or where can we use a momentum impulse and the change in momentum? So the application, then we are going to speak about what seat belts, airbags, and the crumple zone. So remember this one, it represents the crumple zone, and this one, the crumple zone at the back of the car. And then how are you going to explain it? You are going to explain it using this formula here, which says what? The net force is inversely proportional to the what? The net force is inversely proportional to the change in time. So that means that if the net force increases, then the change in time will do what? The change in time will decrease, and that is for the same change in momentum, and that will therefore reduce the what? That will therefore reduce the injuries that a person would have if they were involved in what? In an accident there. Okay, so you need to know how to use this formula over here. So if you increase, you will say that if you increase the net force, the time of contact will do what? The time of contact will be decreased, and that is for the same what? That is for the same change in what? For the same change in momentum. So normally this question in the exam is about 3 or 4 marks. So you need to be able to state the application of momentum impulse and the change in momentum, and then you also need to know how to use this formula or to explain the statement there. So 1.1 there, it says linear momentum can be described as, okay, so when we think of momentum is what? Is P is equals to what? P is equals to mv. Okay, so it can be described as what? So number one, we know that we said that momentum is a what? Momentum is a vector, and then the velocity is a what? The velocity is a vector as well. So if momentum is a vector, it therefore means that the momentum will have what? It will have magnitude and what? Magnitude and the direction. Okay. So the first one there, let us have a look at the option. It says a scalar quantity with no direction. So we know that that will not be our answer. And then, so we are eliminating now. And then let's have a look at option C, a scalar quantity in the same direction as the velocity of the object. Because it's a scalar, we know that that will not be our option there. And then let's have a look at the other options. So option D says a vector quantity in the opposite direction as the velocity of the object. Okay. So this one, it says it is a vector quantity. So that is correct. Momentum is a vector quantity. Okay. So if it's a vector quantity, what's the next step? It says in the opposite direction as the velocity of the object. Okay, so what does this statement mean? We are now saying that, for example, if this velocity, so if the object is moving to the right, meaning that the direction for the velocity is also what? The direction for the velocity is also right. It therefore means that the momentum will also have a direction of what? Of to the right. So it therefore means that wherever the velocity is moving, that will also be the direction of the what? The direction of the momentum. So now let's read again. Linear momentum can be described as a vector quantity. We said we agree that it's correct. In the opposite direction as the velocity of the object. So this statement is saying that if the velocity is to the right, then the momentum is going to be to the left. So we can see that that is going to be what? That is going to be incorrect. So the correct answer should be what? The correct answer should be a vector quantity in the what? In the same direction. So in the same direction as the velocity of the object, meaning if the object is moving to the right, then the momentum will also be to the what? The momentum will also be to the right. So it therefore means the correct answer for us will be what? Will be the letter B. Next one, the photo below shows a policeman who is target shooting at a range. The target with a mass of what? Target with a mass of 1.8 kilogram moving towards the policeman. Okay, so there's the target. The target has a mass of what? 1 kilogram. Where is it moving? It is moving towards the policeman. Okay, towards the policeman with a velocity of, so we are given the initial velocity. So you need to make sure that you what? You collect the data. And then velocity of 2 meters per second, and then an 8.3 gram bullet leaves the barrel of the gun with a velocity of 150 meters per second. So we have a bullet. Where's the bullet? The bullet is in the gun. And then the bullet has a mass of what? Of 8.3 what? 8.3 grams. And then with an initial velocity of what? With an initial velocity of 150 meters per what? 150 meters per second. Okay. So the target is moving towards the person, and then the bullet is moving towards the target. And then what happens? The bullet becomes embedded in the target after the hit. Okay. So what is the first thing that we see? In order to prepare for the calculations, we can already see that we have what? We have grams there. So you need to make sure that you know how to convert there. Okay. So let us move on to the next one. It says the photo below shows a policeman. So it's the same statement, right? And then 3.1 says state the principle of conservation of what? The principle of conservation of linear momentum. So the total linear momentum of an isolated system remains constant or is conserved in what? In magnitude and in direction. So again, remember your definitions, either 2 marks or nothing. And remember, you need to define according to what? According to the examination guideline. Now it says calculate the velocity of the bullet and the target after the collision. Okay, so remember everything that we have been given so far, the velocity, the 2 meters per second, the 150 meters per second, those were all the initial velocities. So now it says that we need to calculate the velocity of the bullet and the target after the collision. Okay, so after the collision, we only have information based on before collision. So which formula are we then going to use there? It's going to be the sum of the momentum initial or before collision and the sum of the momentum final, that is after the collision. So therefore, you are then going to break down your formula to say momentum initial for B, which is the bullet, and the momentum initial for T, which is the target. So what is it that we have? We have the mass and velocity of both the bullet and the target. And then they said what happens? The bullet becomes embedded in the target after the hit. So if the bullet is going to become embedded, then what does it mean? It means that you are now, so becoming embedded, it means that it's going to move together. Okay, So it therefore means that now the mass of, you are then going to add the mass of the bullet and the target so that you can calculate what? So that you can calculate your final velocity there. So what are you going to do? You substitute in the mass of the bullet. What is the mass of the bullet? We said the mass of the bullet is what? Is 8,3 what? 8,3 grams. So what are you going to do? You need to convert from grams to kilograms. So therefore you are going to divide by what? Divide by 1,000. And then what is the velocity of the bullet? We said the bullet has an initial velocity of 150. So you substitute. And then what is the mass of the target? The mass of the target is 1,8 there. So we substitute. And then because we now have two different directions, right? So it said that the target with a mass of 1,8 kilogram is moving towards the policeman. So it was the 2 meters per second. It was towards the policeman with an initial velocity of 2 meters per second. And then the bullet leaves the barrel of the gun with a velocity of what? 150 meters per second. So the velocity of the bullet was 150 meters per second. And then the velocity of the target was what? Was 2 meters per second. Okay. So if we have a positive 150 meters per second here, it therefore means that we chose the left or towards the target as what? As positive. And then it means we chose towards the person as what? That direction, it means that we chose it as negative, and hence that's why we have a -2. So from there, what are we going to do? Remember, we said we are then going to add the mass of the bullet, which is 0,0083, plus by the mass of the target. Why are we adding the two masses? Because we said that they become embedded, right? Then we can calculate the what? We can calculate the final velocity. So we then calculate, so you punch into your calculator and then you calculate the final velocity. And then if we're getting a negative answer, we said a negative answer is towards what? A negative answer will be towards it's moving towards the person, because we chose that direction as negative, and then a positive one, it means that it's going to be moving towards the target. So remember, when it comes to momentum, we don't leave our answer as what? We don't leave our answer as negative. So you will then write the negative answer, and then you write the positive answer. From there, you will then write your direction there. Next one, it says determine by calculation whether the collision was elastic or inelastic. So remember, we said that if it is an inelastic collision, what are we going to do? It therefore means that the momentum before is equal to the momentum after the collision, but the kinetic energy before is not equal to the kinetic energy after. So what are you going to do there? It therefore means that you are going to calculate the sum of the kinetic energy before the collision and the sum of the kinetic energy after the collision. Okay, so from there, half mv squared, you substitute the mass there, the velocity, the mass, the velocity, and then you can calculate your answer there. And then on the next one again, remember we said that, so it's going to be half. So with this one, remember we said that the bullet becomes embedded into the target. So that is why we are going to have a combination of the masses, and then on the previous question, we calculated the final velocity. So we therefore substitute so that we can calculate our answer as what? As 1,53 joules. So now what are we saying? The sum of the kinetic energy is not equal to the sum of the kinetic energy after the collision. So therefore the collision was what? The collision was inelastic. Okay. Next one, we have work, energy, and power. So again, 2 marks for the definitions. So those are the definitions that you have in terms of the examination guideline. And then you need to state the principle of mechanical energy there. Then draw a free or a force diagram, and then we also have what? We also have formula and the substitution. Okay. So with a free body or a force diagram, we are saying that you can at least get a minimum of what? Of 3 marks. It's just a minimum, so meaning we can get 4 or 5 marks, right? So without even you doing any calculations, how many marks are you then going to collect there? You can at least calculate, collect about 9 marks. But if maybe let's say that you only have to state one definition, you give the free body diagram, and then for the formula and substitution, so therefore you can at least collect about 7 marks there. Then we also need to make sure that you are familiar with what? Make sure that you are familiar with the formula sheet. So we are going to use these formulas here. That's the formula for work. And then what's important here is that work is a scalar quantity. So meaning that when you get a negative answer, you are no more going to say that it's moving to the left or it's moving to the right. Okay, so negative answer just means that there was a loss in energy. Positive answer just means that there was a gain in energy. Okay, so that's your formula for the kinetic energy. So all the two formulas, and then this one is the formula for the average power, gravitational potential energy, and then this one will represent the formula for power there, and then this one mechanical energy. So you need to make sure that you are familiar with your formula sheet there. Now, when it comes to positive work, okay, when it comes to positive work, so now let's say this is now your free body diagram there. So normal force, gravitational force, and then let's say on the right we have the applied force, and then on the left we have the kinetic friction there. So when it comes to positive work, we are saying that it is when the displacement is in the same direction as the applied force. So the displacement, we can see that the displacement here, yes, the displacement is in which direction? Is to the right. Where is the applied force? The applied force is also to the right. So there's your displacement. The displacement is in the same direction as the applied force. So when that happens, we know that for positive work, then we have cos what? We have cos 0. Okay? That is when you'll have a positive work. That is when you'll have a positive answer. But when it comes to negative work, we are saying it is when the displacement, there is your displacement, is in the what? Is in the opposite direction now. Is in the opposite direction of what? Is in the opposite direction of your kinetic friction there. So there is the displacement, and then there is your Fk. So that between the displacement, if I can write it here, between the displacement and the Fk, what is the angle between the two? So it's going to be this side, we have 90 degrees plus by what? Plus by 90 degrees. So 90 plus 90 is what? Is 180 degrees, okay? So when we have negative work, for example, with what? With the Fk, we are therefore saying that it is when we have what? Cos 180 degrees, okay? So when we have cos 180 degrees, we know that the answer here will be -1, and then the answer here will be +1. Then next, when we have zero work, what are we saying? It is when the displacement is at a what? At a 90-degree angle with the normal force or Fg there. So there's the displacement, and then there's your normal force. So what is the angle between the two? The angle between the two is what? Is 90 degrees. So that is when we'll have cos of what? Cos 90 degrees. And then when we have cos of 90 degrees, what is it going to give us? It's going to give us 0. And then again, with the gravitational force, we are therefore saying that the displacement and the Fg, what is the angle between the two? The angle between the two is cos is 90 degrees. And then if you then say cos 90 degrees, it will therefore give you what? It will therefore give you 0. So what are we saying with all of this? We are saying that the applied force will do what? The applied force will do positive work. Why? Because the displacement and the applied force are in the same direction. But we are saying when it comes to negative work, the displacement and the applied and the friction or the applied force in this case are in opposite direction. If they're in opposite direction, it means that you are going to have cos 180 degrees. If you have cos 180 degrees, you'll get a negative answer. Negative answer means negative work is done. And then for the normal force and the FG, we are saying that the displacement and the FG, the angle between the two, is 90 degrees. When the angle is 90 degrees and you calculate cos 90 degrees, you will get what? 0. When you calculate the 0, we are saying that it therefore means that 0 work is done. So 0 work will be done where? On the normal force and the gravitational force there. Okay. Then conversions. So you need to make sure that you know how to convert. So it says kilograms to grams. What must you do? You need to divide by 1,000. Divide by 1,000. So to convert from mass, which is what? From your grams to kilograms, you divide by 1,000, and then to convert from meters to centimeters, you need to divide by centimeters to meters, you need to divide by what? Divide by 100. And then kilometers per hour to meters per second, we need to divide by 3,6. And then to convert from kilowatts to watts, we multiply by 1,000. And then from horsepower to watts, we need to multiply by what? By 746. So these are not all the conversions, but just make sure that you familiarize yourself with all the conversions that we have there. Okay. Then the next one says a block is moved to the right by a force F. Choose the diagram where the force F does positive work on the block. Okay, so we spoke about this one. This one, as an example, it can be representing what? It can be representing the normal force. So we know that if that is the normal force and the object is moving to the right-hand side, therefore the angle between the two will be what? Will be 90 degrees, okay? So it's because it says a block is moved to the right. So if it's moving to the right, this will be your displacement. That will be your Fn there. So the angle between is cos 90. So we know that cos 90 will give us what? Cos 90 will give us 0. So it will not do positive work. And then this one, if it's moving to the right, with that angle there, so that angle is on the opposite direction of what? Opposite direction of change in x. So if it's on the opposite direction, we therefore know that it will not give us positive work. Again, the object is moving to the right. What is the angle here? 180 degrees. 180 degrees is cos 180 degrees. If you put that in your calculator, it will give you -1. If it's -1, we know that that is when we are going to have what? Negative work done. So the only option left is what? We have the applied force. The displacement is also to the right. So if that's the case, it means that we will have cos what? Cos 0. And then when we have cos 0, our answer there will be 1. So therefore the direction, therefore the positive work will be done when it comes to option what? When it comes to option B there. That is our correct answer. Okay. So the next one, it says a girl pushes a 6.5 kilogram box across a rough floor, okay, by applying a 20 Newton force to the east. The coefficient of kinetic friction between the box and the floor is what? Is 0.1. Then it says the block moves a distance of 0.2 meters. Okay. So because they spoke of a rough floor, then immediately we know that they are talking about what? They're talking about the friction. So the block moves a distance of 0.2 meters. 4.1.1, so define energy. What is energy? The ability to do work. So remember definition, it will be 2 marks or nothing. 4.1.2, write down the names of the two forces that act on the block, but do what? But do no work on the box as it moves over a distance of what? Of 0.2. So remember we spoke about that. What are the two forces that are going to be doing no work? So it will be your normal force and your gravitational force. Why? We said that if the object is moving to the right, so that is like your displacement. What is the angle between the displacement and the normal force? We said it's 90 degrees. If you say cos 90 degrees, it will give you 0. So the work done is what? The work done is 0 work there. And then again, the angle between the displacement and FG is what? Is 90. Again, cos 90 degrees will give you 0. So it therefore means that 0 work is done. So it will be the weight, which is Fg, or the gravitational force, or the normal force there. Okay, the next one, it says the block moves a distance of what? The block moves a distance of 0.2 meters. 4.1.3, we need to calculate the work done by what? The work done by the girl on the box, okay? So again, it therefore means that we are going to use what? We are going to use our formula then. Where are we going to take the formula? We are going to take it from the formula sheet. So it is the work done by the girl is equals to, we can say the force applied, change in x, and then what? And then cos theta, okay? So what is the force applied? The force applied is what? The force applied is the 20 there. And then what is the displacement, or over a distance of what? Of 0.2. So we substitute the 2. So remember, we said what here? So if that is the normal force, that is the gravitational force, and then that is our applied force there on the right. So we said that the object is moving in which direction? The object is moving to the right. Now, what is the angle between the displacement and the applied force? The angle between the displacement and the applied force is 0. Why? Because it's moving in the same direction. So from there, we calculate the work done by the girl, and it's going to give us an answer of what? Of 4 joules. Next, calculate the net work done on the box. So now they want to know about all the work done on the total work done on the box. Okay. So remember, we spoke about what? They spoke about a rough surface. Okay. So if they speak about the rough surface, it therefore means that we have what? We have the kinetic friction. So the same goes for the for work, energy, and power. You also need to know how to draw a free body diagram. And then we therefore said that a normal force and the gravitational force, they're going to do what? 0, 0 work. So it therefore means that we are not going to calculate the work done by the normal force and the gravitational force there. So we have calculated the work done by the girl, which is on the right-hand side to the applied force. It therefore means that we can now calculate the work done by what? The work done by friction. So what are we going to do? We are going to use this formula. Where do we get the formula? On the formula sheet. And then, so it's the work done by friction is F for friction, change in x and what? And cos theta, right? Then, what is the formula of friction? Formula of friction is Fk mu k multiplied by what? Multiplied by the normal force, right? So from there, we have mu k. And then what is the formula of the normal force? So this one is just on a horizontal surface. So it means that the normal force, so normal force Fn will be equals to what? Will be equals to Fg. So therefore mu k, when we break it down, it becomes what? Mass times the gravitational acceleration. So now it therefore means that we can then substitute the coefficient, which was given as 0.1. We can substitute the mass of the mass there of the box, which was what? 6.5. gravitational acceleration constant, and then which we can get on the data sheet, and then we can then substitute the distance, which is 0.2. So now what is important on this one? It is friction. So because it's friction, it therefore means that the angle will now be what? Will now be 100 and what? Will now be 180 degrees. Okay? So from there, when you are done, what is it that you are going to do? So the answer for this one is then this one here, negative 1, what? Negative 1.27. So when you are done, you are therefore going to say the network done by the girl, which is your applied force, and the network done, and the work done by friction is therefore what? The work done by the girl was 4, and then the work done by friction is what? Is negative 1.27. So therefore, it's 4 minus 1.27, and then that should give you an answer of what? Of 2.73 joules. So with work, when you get the answer as a negative, you don't now change the answer and make it a positive when you substitute into the formula. So you take the answer as it is, as that negative, you substitute it into another formula, and then from there you are able to calculate your what? You are able to calculate your answer there. Next, we have elasticity. So again, you need to be able to define the definitions of elasticity, be able to state Hooke's law, and then formula and substitution for stress, strain, and the elasticity modulus there. Okay, so with this one, we are saying that you should at least familiarize yourself with what? With this one here, which is the formula for what? For stress. And then this one, which is the formula for strain. And then this one is elasticity modulus. So make sure that you familiarize yourself with the formula sheet. And this one is under the heading what? Elasticity, viscosity, and what? And hydraulics there. So make sure that you know those formulas and you know how to apply all those formulas. So with this, we are saying that at least if you are able to define, you are able to state the law, and you are at least able to write the 3 formulas and substitute, because remember, if you don't substitute, then you are not going to be getting any mark for the formula. So make sure that you write the formula and then you substitute. That is where you are going to get a mark for what? That is where you are going to get a mark for the substitution. Okay. So that one, you should at least get about 7 marks there. But let's say now you only have to give the definition and and maybe write the formulas. Then we are then saying that you can at least get a minimum of what? Of 5 marks. Depending on the formulas, if maybe you have to provide one formula, you can then get a minimum of what? A minimum of 4 marks there. Right? So now we have this question here. A steel rod is 1 meter long. Okay. 1 meter long with a cross-sectional area of what? Of 0.5 centimeters squared. It stretches by. Do you see that we have so many conversions here? So we need to convert this one. We need to convert this one. When a force of magnitude 6,000 Newton is applied as shown below, then 5.1.1 state Hooke's law in words: within the limit of elasticity, stress is directly proportional to the strain. Again, remember definition. You need to define according to the examination guideline. Then we have a 5.1.2. It says calculate the Young's modulus of the steel rod. Okay. So for this one, learners, I'm going to ask that we take about 2 minutes, a 2 minutes break. And then when we come back, we can then continue with 5.1.2. Welcome back, learners. So now let us continue 5.1.2. It says calculate the Young modulus of the steel rod. Okay, so what are we going to do there? So it means that we must now know the formula of what? Of stress. So what is it that we have there? We have a force of magnitude of what? Of 6,000 there. And then we also have the area of 0.5 centimeters squared. So remember, for us to convert from centimeters to meters, what is it that we are going to do? We are going to divide by 100. But now, because we have centimeters squared, it's going to be divided by what? Divided by 100 squared. And that should give us 5 times 10 to the power of what? 5 times 10 to the power of -4. So now we then calculate, and that should then give us our answer of stress in what? In pascals. So next, we need to calculate the what? Next, we need to calculate the strain there. So the strain is the change in length divided by the original length. So what was the change in length? The change in length was 0.24 centimeters. So 0.24 divided by 100, and then what do we get? It will give us 0.0024. What was the original length? The original length was 1 meter. So because it was the 1 meter, we therefore write it as it is. We don't need to convert. And then that will give us our strain, which is 0.0024. So remember, for the strain, we are not going to be writing what? We don't have units for strain. Then to calculate the Young modulus of the steel rod, we are therefore going to say stress divided by the strain. So we just take the answer that we got in terms of stress and the answer that we got in terms of the strain there. And that should give us what? 5 times 10 to the power of 9 what? Pascal. So where's the Pascal coming from? Remember, we said the stress, which is this one, the unit is what? Is Pascal. But the strain, we said what? We said no unit. So therefore, it's the Pascal divided by no unit, or divided by 1. And that should give us a unit of what? A unit of Pascal. Okay, so take note, the unit of what? Of the Young modulus will be the same unit as what? Will be the same unit as the stress there. Okay. Then next we have a hydraulics and viscosity. So again, remember, you need to give what? You need to give the definition there. Be able to state Pascal's law. Number 3, applications of hydraulics principles and the application of Pascal's law. So just make sure that you know those applications. And we are saying that at least there could be a minimum of 1 mark, and then formula and substitution. So you must make sure that you know your formulas. And then in terms of the viscosity, the effect of what? Of temperature on the viscosity of liquid. So we know what is the relationship between the two. They are inversely proportional. So if you have an increase in temperature, you'll have a decrease in what? You'll have a decrease in the viscosity. So where do we find those formulas? We find them under elasticity, viscosity, and hydraulics. So those will be your formulas there for this topic here. So again, we are saying that you can then collect about 7 marks from the definition, the application, and from the formula. Then next one there, we have, it says, in a hydraulic lift at a service station, a man exerts a force on a small piston A with an area of what? 800 centimeter squared. Okay, so when we see this one, immediately we know that we need to do what? We need to convert, because we don't work in centimeters, but we work in what? In meters. The pressure is transmitted by an incompressible liquid to a second piston B with an area of what? 2,400 centimeters squared. Now, if the man exerts, so this is the man here, this man is exerting a force of 784 Newton on piston A, will he be able to lift the car with a weight of what? With a weight of 9,800 Newton here. So will he be able to lift this car? that has a force of 9,800 Newton at piston B. Use a calculation to motivate your answer. So what is it that you are going to do? You are going to use your formula sheet there, and then you substitute there. So what is it that we have? F1 and A1. So F1 and A1. So F1 and A1 is this side, and then we have F2 and what? And A2 this side. So for F1, we are looking for F1. Do we have A1? Yes, we have A1 is 800 centimeters squared. Remember, we said to convert from centimeters to meters, we are going to do what? Divide by 100. But then if we are converting from centimeters squared to meters squared, we are going to divide by what? By 100 squared. So it's 800 divided by 100 squared. It gives us 800 times 10 to the power of negative 4. F2, we have F2, so we just substitute. And then we have what? 2,400 centimeters squared. Again, what are we going to do? Divide by 100 squared, okay? So that then gives us, it then gives us what? A force of what? Of 3266,67 Newton. Now the question says, if the man is exerting 784 Newton on piston A, will he be able to lift the car? So the car has 9,800, but the man is lifting with what? With 784. Is it possible for this man to be able to lift off this car? Now, after calculating, we find that we are getting a force of what? We are getting a force of F1. So therefore, the man will not be able to lift the car at what? At piston B. Why? Because the car already has a force of what? 9,800, and that force is greater than the 3,266,67 that we got there. Next, we have electromagnetic radiation. So in terms of the electromagnetic radiation, we need to know a definition. So definition 2 marks there. Know at least a minimum of 3 or 4 properties of the electromagnetic waves. Know how to use the formula, and then know the uses of electromagnetic waves. Okay, so these are the formulas that we have when it comes to the formula sheet under wave, sound, and what? Wave, sound, and light there. Okay, so now in terms of the electromagnetic spectrum, remember we said we are going to use this. Refilwe Mukwena went for an intense visit in Uganda to do what? X-rays and gamma rays. So with all of that, it means we have radio waves for Refilwe, microwave for Mukwena, infrared for went for an intense visit, visible spectrum for visit, ultraviolet for Uganda, X-rays, and then gamma rays. So we must just remember to have the following, which is radio waves, microwaves, infrared, visible spectrum, ultraviolet, X-rays, and gamma rays. Okay, so now when it comes to the gamma rays there, we need to remember that we have what? We have frequency. At the bottom, the gamma rays have a higher frequency, and then higher frequency and higher what? Energy. Why? Because frequency and energy are what? Are directly proportional, okay? But then at the bottom here, we have what? A shorter or a lower wavelength. Why? Because frequency and wavelength are inversely proportional. So it then means that if here you have a higher frequency, you'll have a lower frequency here, lower energy, and a longer or a higher wavelength there when it comes to what? When it comes to your radio waves. Now we also need to make sure that we know the types of electromagnetic radiation. So we already know the types. And then when it comes to the types as well, we also need to make sure that we know the uses for all of them. So these are just some of the uses. You just need to make sure that you go and study other uses in terms of the electromagnetic spectrum, and then you'll be given marks accordingly, according to the marking guideline there. So it says the diagram below shows the electromagnetic spectrum. Give the names of the waves that are represented by the letters A, B, C, and D. So remember we said that we are going to use what? We are going to use this R, M, I, V, U, X, and G. Okay. So what is it that we have here? We can see that we have what? We have radio waves. So if we have radio waves, it means that the first letter here is represented by what? It's represented by the gamma rays. And then if this is the gamma rays, the next one is X-rays. Therefore, it means that the letter B is represented by this one here, which is your UV rays or ultraviolet rays. And then from there, we have what? We have the visible light, which is the letter C. After visible light, we have infrared. And then by letter D, what is it that we have? We have the microwaves. And then this one should therefore be your radio waves there. Then which wave series has the shortest wavelength? So remember we said that frequency and the what? The frequency and the wavelength are inversely proportional. So it therefore means that if gamma rays has a higher frequency, it will therefore have a shorter wavelength. So we know that the gamma rays, they will have the highest energy. Therefore, they should then have what? They should then have the shortest wavelength there. So our answer for this one will therefore be what? It will therefore be the gamma rays there. Then infrared light has a wavelength of what? Of 50 micrometer. So remember with this one, we also need to know how to convert there. 7.2.1, it says define what? A photon. It says a quantum of what? A quantum of energy. Remember, you are going to define according to the what? According to the examination guideline. 7.2.2, calculate the energy of the infrared light. What are you going to use? Your formula sheet there. So what do you have? E is equals to hc. So familiarize yourself with the constants. H is Planck's constant, and then c is the speed of light. And then this one, lambda, what does it represent? It represents your wavelength there. So then what are you going to do? You are going to therefore substitute a Planck's constant, the speed of light, and then you need to make sure that you convert this one. So if it's a micrometer, we multiply with 10 to the power of negative 6. And then if it's nanometer, we multiply with 10 to the power of negative 9. Picometer, we multiply with 10 to the power of negative 12. So just make sure that you know those conversions there. So from there, we are therefore going to calculate our answer, and we get our answer is 3.98 times 10 to the power of negative 21 what? Joules. So that should therefore be our energy there for 3 marks. And the next one, we have light. So for light, make sure that you know what? You know the definition. So we are saying that when it comes to the definition, you can get 2 marks. Be able to state the law of reflection and the law of refraction, another 2 marks. Be able to draw the ray diagrams, and then be able to write the properties of the image formed by a concave and a convex. That means that you must first be able to differentiate between what? A concave and a convex lens. And then at least know the application in terms of the convex and the concave. Number 6, know the following for lenses. Remember that diagram that shows what? The principal axis, optic axis, focal length, and the focal point. Make sure that you know that diagram. Remember, this diagram is the one that is going to help you to be able to draw whatever image that is formed. So we are saying that at least if you have this knowledge, you can then therefore be able to collect about 9 marks there, about 9 marks out of about 25 or 15 marks in terms of the light there. Then we have total internal reflection. It says when the angle of incidence is greater than the critical angle, the ray of light reflects into the original medium. So just to remind you here, you must make sure that you know how to label the incident ray and the angle of incidence, refracted ray, and the angle of what? Of refraction. So this part here, it represents what? Refraction. And then just to remind you on the critical angle, it is when the refracted ray is in between, lies in between the 2 mediums of 2 different what? Optical density. Remember, this one is A, which is less dense, And then this one is water, which is more dense. And then we also have what? The total internal what? Total internal reflection. So with the total internal reflection, it says when the angle of incidence, so this is the angle of incidence, is greater than the what? Is greater than the critical angle. So remember, this one was the critical angle when the refracted ray was in between the two mediums, right? So with the total internal reflection, we are saying when the angle of incidence, so this one from the critical angle is greater. So when this one is greater, meaning when it increases, so from here to here, this angle has now increased. When it increases, it says the ray of light reflects into the original medium. So remember that ray of light, it was here, it was in between the two mediums. So the ray of light will do what? Reflect into the original medium. What was the original medium? It was water. It has now reflected back into the original medium there. Then just to remind you on dispersion, it says the phenomenon whereby light breaks up into its component colors. So for this one, we should know what? Roic beef. So roic beef is what? Red, orange, yellow, green, blue, indigo, and what? And violet. So again, for this one, at the bottom here, in terms of the violet, we have a high frequency. And then we are saying that the frequency is directly, the frequency is inversely proportional to what? Is inversely proportional to the wavelength. So just take note of that, and then you can use that to remember the colors. And then frequency of light stays constant irrespective of the, so this statement is very important. It says the frequency of light, it stays constant irrespective of the medium in which it propagates. So just remember that, and then wavelength is directly proportional to the what? To the speed. Very important. So if you have a high frequency, shorter wavelength, then the less the what? The less the speed. Why? Because we are saying that the wavelength is directly proportional to the speed. Meaning if the wavelength decreases, the speed will also do what? The speed will also decrease. Okay. So this one says a ray of light travels from air to glass at an angle of what? Of 35 degrees as shown in the diagram below. Then it says A and B represent the media through which the light is traveling. Okay. Write down the name of each of the following angles as shown. Okay. So the angle marked as what? The angle marked as 35. So the one that will enter the glass block, we call that the what? We call that the angle of what? The angle of incidence. And then this one, the angle that is marked as X. So this one, the one that is going out of the glass block. So we therefore call that the angle of what? The angle of emergence. And then write down the value of the angle what? The value of the angle X. So what is it that we know? We know that the angle of incidence must be equal to the angle of what? To the angle of emergence. So therefore, the answer will be what? Will be 35 degrees. Because as the angle of incidence, we have 35 degrees. Therefore, the angle of emergence is what? Is also 35 degrees. Now it says name the following ray PQ. So ray PQ, what is it that we have? We said the angle is the angle of incidence. So therefore, the ray will be the incident ray. And then ray QR. So for ray QR, we are going to have the what? The refracted ray. So that will be the angle of what? This one will be the angle of refraction. And then ray RS, we said this is the angle of what? The angle of emergence there. So therefore that will be the emergent ray. So they go hand in hand, angle of emergence, emergent ray, and refraction angle, therefore the refracted ray, angle of incidence, therefore the incident ray there. Which one of the two media, A or B, is optically denser? Explain your answer. Okay, so our answer for that one will therefore be what? It will therefore be B. Why is it going to be B? This one, this medium is A. So A is what? A is less dense. This one is more denser. So if it's more denser, what happens to the refracted ray? The refracted ray, this one, it will therefore move towards the normal. So if we are moving from less dense to more dense, we are saying the refracted ray will move towards the normal. But if we are moving from more dense B to A now, we are saying that the refracted ray will move away. This is the normal. So the refracted ray will move away from the normal. But in the denser medium, from less dense to more dense, the refracted ray will move towards the normal. And then in the from more dense to less dense, the refracted ray is going to move away from the normal. Okay. So with that, learners, I'm going to leave you with the words of Nelson Mandela, which says, "It is in your hands to create a better world for all who live in it." So thank you very much, learners, and I hope all the best for your examination for paper 1. And thank you very much. I'll see you next time.